In this video, we're going to resume with symmetry, TRiCkY algebra, part 2. So this is going to be a challenge question. So here's the question. We have 25 equations. I didn't list them all out. We have a minus b equals 1, b minus c equals 2, and so forth, all going alphabetically, and this one's one ahead, all the way till we reach y minus equals 25. So there's 25 of these equations, and the question is, what is z minus a? All right, so that looks kind of intense. So you may want to try to do it on your own. For those of you that want to pause the video and do that, that's great. So assuming you've tried it or you failed, you want to go over it, now let's go over it. So I love this problem. There's at least 3 concepts in this problem. Let's start with the very last one just to get this out of the way. So this is going to be slightly new. We're going to do a warm-up that will go over this concept. So let's say we want to simplify x minus y divided by y minus x. If you haven't seen this, this looks like complete mumbo jumbo, as though I need to give you the values for you to be able to do anything. However, if you know this little fact, if you take x minus y and multiply it by -1, that'll be negative x, and it'll be negative y, so that's positive y, and then we're just going to rewrite it in the other order, so it's y minus x. Notice, if we negate x minus y, we flip it around. So that means, so like for example, if you have 5 minus 3, that's 2. If you have 3 minus 5, that's -2. So if you swap the order, it negates it. Meaning these two are intimately related, the numerator and denominator. The top is the negative of the bottom. All right, or they're called additive inverses. That would be the technical term. All right, so that means this is really just y minus x negated. So these cancel out and we're left with -1. So that's not obvious, but that's why we're going over that right now. So you can make this a little trickier. You could even throw in some weird numbers, and now it looks terrible, right? So you might say, oh, x and y, now the reverse, so there might be some negative thing going on. So let's first try to swap the order, but we'll negate it to account for that. So now we've at least lined up the y's and x's, so that feels pretty good. And next we could see, are these somehow related? Well, what do 9 and 12 have to do with 6 and 8? You might, if you factor out a number over here, you might notice this is going to be -2 times 3y minus 4x. And if you factor out the GCF here, the greatest common factor, that would be a 3. So that would be 3 times 3y, minus 4x again. So notice, because we've swapped it around using our additive inverse noticing of this pattern, and furthermore factoring out whatever they had in common, now this part is the same, so that's gone. So this reduces to just -2/3. My point here, there's sort of 2 main lessons to learn. So one is to be on the lookout for these swaps and negations of each other, and the other, although you don't know any of the x and y values, that doesn't mean you should give up. So you can sometimes find the value of expressions even without knowing the details of the individual variables. So for example, in this problem, you might assume to do this, we must know z and we must know a. That's not necessarily true. All right, so that was the point of this problem. All right, so now we're ready for that problem. So using our previous symmetry skills, if we take a look at this, it sort of looks symmetric, like everything tends to reappear like it's cycling somehow. It's not exactly symmetric, so I'm calling it near-symmetric. But for example, we would need another equation for it to completely loop to have a z minus a, but so it's not exactly symmetric. So what we're going to do is notice, hey, that's a -b, that's a positive b, that's a -c, that's a positive c. So just like in our previous video, we're going to try to combine everything. So let's add absolutely all the equations. So these will cancel. These will cancel. Basically everything will cancel diagonally. So there's going to be a -y in this 24th equation that will get rid of this, but that -z will stay. So once we add everything up, the only thing that will remain will be that diagonally top left a and the bottom right minus z. So that's easy enough. However, this part's kind of annoying. So we're going to have the sum of all of these numbers. But if you remember the special sums video we did a while back, this is not too bad. We can group them and pair them off. So each pair sums to 26. And since there's 25 numbers, there's 25 over 2 pairs. We simplify here. We don't multiply first, we simplify. That's 13. 13 times 25 is 250 plus 75, so that's 325. Now, we're not done yet, because look what we found. We found a minus z, but we wanted z minus a. But if you remember what we started the video with, this should be very easy to do. So all we do is just plop a minus sign and we're done.